welcome to the session. Greeting of the day. In this class, we will see about the types of flames in welding processes. So we need heat for doing the welding. So what is the purpose of heat generation in the welding process? What's the purpose of heat? What we are doing? Why the heat is needed? We know for melting of the filler metal and depositing over the work pieces of number 1 and number 2. That things we know. So that I have given. Melting of the fairing surfaces in the fusion welding. Thermal softening, maybe heat treatments are making the ductile properties. So for the plastic states, that also in the resistance weldings. Melting of the filler and the heating, melting of the filler. So both these are interlinked. Fairing surfaces is nothing but the workpiece. So this is the fairing surface. So this region is the fairing surface. And then melting of the filler wire also. Both to be in contact, then only the joining occurs. So it is to be heated, that is to be heated. So melting of the filler wires and also used in the brazing, solderings. Okay, so those things that we know, we come across such that heat required for making the joining process. Now, next process I'm starting the classifications of welding. We have seen about the various list with respect to heat, with respect to filler, with respect to mechanicals of friction, with respect to resistance. So various classifications we have seen. From that I'm starting with respect to first the gas welding process, and on that the types of flames we have to see. From that gas cutting, gas welding, both are related. We are going to use the same setup of oxy-acetylene gas cylinder setup. When the nozzle changed, if a flame setup has been changed to the neutral flame, we can go for welding. When the same setup has been changed for oxidizing flame, we can go for cutting. When the same setup is changed as a carburizing flame, we can go for the heat treatment or hardening processes. So that is how we are going to see. In the gas welding process, Oxyfuel Welding process. Fuel we are using as an acetylene. Okay, it's a manual welding process. Yes, we know, which is that the metal surface to be joined or melted progressively by heat from the gaseous flame. So this is what now we have to see. We are using the oxygen and the acetylene. When these two are come together, generates the heat by its chemical reactions. That we are using and melting and welding. So with or without filler wire, so that is okay. And solidify without the application of pressure. So here pressure is non-applied. We have classified the welding process into pressurized welding, non-pressurized welding. Non-pressurized welding is nothing but a fusion welding process. Pressurized welding, whether the mechanical force is applied. Here the gas flames, there is no pressure. Just flames are mixed, chemical reaction takes place, heat is generated, that heat is utilized for melting and joining. How I am doing here, I have made like an equation format. Okay, so how I am doing, oxygen plus fuel gas. What is it fuel gas? It is nothing but acetylene. C2H2 acetylene I have taken. Oxyfuel gas welding formed. Maybe oxyfuel gas welding, or otherwise we can do cutting. We can do this cutting method also. Gas is used to produce the arc. The gas produces the arc in such a way we generate a heat, and therefore such a heat utilized for welding purpose that we know. Commonly used fuel gases for us in the hydrogen and those things are given. Oxyacetylene welding is one of the popular oxyfuel gas welding process. Oxyfuel they are given. They have not mentioned oxyacetylene welding, but this fuel we are using, this is acetylene. This fuel they are using, this is acetylene one. Others also can be used, but mostly the intensity of heat generated high at this acetylene. Therefore, oxyfuel used as an oxyacetylene welding process. Heat required for welding is obtained from the flame generated. Yes, carburizing flame, neutral flame, normalizing flame. So due to oxyfuel mixture of combustion takes place, the flame results at the tip of the torch is sufficient to melt the joint in the parent material. The filler metal U rod is generally added. So what I am doing here, in case for cutting, I have a specimen and have a gun specimen here. I have a gun, right? Here I am supplying, we have to see elaborately, I am supplying a neutral flame for welding. How it will weld? Here I have two specimens. This heat is generated. It is not autogeneous welding. Filler wire, high thickness are there. Filler wire to be added. So on this gun, neutral flame, actually neutral flame will come. On that we have to add the filler wire here. In this side we are adding the filler wire. So the filler wire, the heat will be passed over the filler wire and it melted and it deposited. And it will be deposited. No, I am not using this filler wire. Now I am going for the cutting process. So the same gun I am taken. Same gun I have to take. And then the workpiece. And then the workpiece I have to take. Now it's a cutting process, not the welding. So we can skip this center line. Okay? We are going some hole, or cutting or edge preparation, something we can consider. So what I am doing here, instead of neutral flame, I am using the oxidizing flame. This we have to see how to change the neutral flame, how to change the oxidizing flame, we have to see. So I am supplying the oxidizing flame. So what happened? It oxidizes the material. I am increasing the oxygen content on the material. I am forcing this oxygen. I am forcing over the workpieces. What happened? The oxidizing process happens. We have seen these things. The word oxidizing in the metallurgy. So this oxidation creates the erosion of the material. Therefore, when this oxidation happens over the material, the surface removed, or it is edge preparation, the cutting, or the hole preparations, putting the hole perpendicular, the hole oxidation, it is this area is removed, it comes down. Okay, so this oxidation can be used for cutting process. No, what I want to do now, I would like to make a heat treatment process, a carburizing. It means the same gun is used again. See, the same gun is used again, and I want to make this zone harder. We have studied in the metallurgy that increasing of the carbon content increases the hardness. This we have studied. So this we are applying here in terms of carburizing. How we are applying? Here we have neutral flame. We have increased the oxygen. It become oxidizing cutting process. And from the neutral flame, neutral is nothing but a 1:1. 1:1. It means oxygen ratio C2H2 is equal to same ratio. Here the oxidizing flame, oxygen will be greater. Oxygen is greater than C2H2. Okay. Here what happens? Oxygen less than C2H2. Here the carbon is there. Okay, acetylene is greater than that of the oxygen there. So what happens? This carburizing will fall on the surfaces. So here it will form. So what happens? Carburizing treatment happened there. No cutting, no welding. It is one of the carburizing heat treatment method, increasing the hardness. So for these three categories, I am using the same single gun and the same cylinder of oxygen and acetylene. What I am doing? I am changing the type of flame. Equal oxygen and acetylene. Oxygen is greater than acetylene. Oxygen is less than acetylene. So this is a idea we should see now. Right. So Oxyfuel welding setup. What I have told you is the simplest and most frequently used Oxyfuel welding system consists of. We have seen this This setup we have already seen in the various shops when you are roaming around there. The compressed gas cylinders. Here, the oxygen always in the industry it is denoted in the black color. Keep remember. It is one of the objective type. Cylinder in the black color represents the oxygen, and the other color represents the acetylene, a dark grey or the red color. Those brown or dark brown color represents the fuel cylinder with respect to what is this fuel? We know this fuel is now as C2 acetylene. Okay, the compressed gas cylinder, gas pressure regulators. So here we have the regulators. How much? Oxygen to be greater, oxidizing, acetylene to be greater, carburizing, both to be equal, 1:1 ratio, neutralize the flame. So when we have to supply to the gun, on the gun the flame source comes out. In case if it is neutral flame, I am using here neutral. When it is welded, I am using the carburizing flame, heat treatment. I am using the oxidizing flame. Then it is a cutting process. So this nozzles plays the important roles. So gas pressure regulators, hoses for the connections, and the welding torch. The same torch with respect to flame changes. We are doing three processes: cutting, heat treatment, welding. Right. So oxygen fuel gases are stored in the separate cylinders. Yes, you understand, right? And then at the top, the gas passes through an inlet control valve. The valve. We are talking about the valve now. Through tubes within the handles and into mixing chambers, of the welding nozzle. Here the mixing chamber. Here, there. You see? Here. It will mix to, and then the mixer gas then passes through the welding tip, and produces a flame at the exit end of the tip. So the flame comes out of the exit. Maybe these three flames. Okay. Filler metal if needed. If needed, we can able to add for addition for the welding purpose of the thicker material. For thinner material, autogenous welding can be done. Just heating, light heated, and as it is, it will lightly melted and welded. Such cases. So I am coming down. Oxygen and acetylene are mostly used in the oxyfuel welding process. Oxygen supports the combustion of the fuel gas. So how this reaction takes place, oxygen and acetylene. So oxygen takes care of the combustion of this generation of heat, and acetylene supplies both the heat intensity and atmospheric need to the welding steels. Okay, so both when it is combined, the heat is generated, but heat we are using for welding purposes. So please remember this slide we have to see at the last. I have given the flames, fuel gases, acetylene, and the three oxidizing, neutralizing, carburizing, and I have given the list. And the flame oxidizing, neutralizing, carburizing, and I have given the list. What is the inner cone? How the cone appears? Middle, outer. This we have to see again at the last. So see the chemical reaction of the gas welding methods. Heat generated from the combustion of fuel gas, for example of acetylene and the oxygen. You see the various gases I have taken, such as acetylene, propylene, propane, hydrogen, natural gases. So from this consideration, see the temperature at the last column. This acetylene having the highest temperature, creation of temperature of 3100 degrees centigrade. 3100 degrees centigrade. Therefore, it is comparatively higher than that of all the other fuel gases. Therefore, acetylene is the most preferable one, because it is high temperature. Why need to go for other gases? Why need to go for hydrogen? Why need to go for propane? Because there are already low temperatures. We don't need to use. We need high heat, immediate melting, joining. So the peak temperature at acetylene gives increased melting rate. Therefore, increased welding speed also. We can do fast heating. We need If it is heated, why need to keep on heating? You can go for the next welding, next heating spot, next heating spot. So we are using the acetylene as a major source. So I came to the typical structure of oxyfuel flame. Neutral and oxidizing flames are given here. So what? I have taken the torch tip. This is the torch tip, and then the inner whiter cone is around 3100 degrees in the same temperature we have seen. See, the same temperature. This temperature we have seen now. 3100 degrees centigrade inner cone having this one. So we are taking the acetylene as a top, which is used. Inner cone is 3100 degrees centigrade. What about other one? So inner cone looks, how it looks, we are classifying the shape of the flame. Types of flame we cannot able to tell. This is neutral flame, this is oxidizing flame, this is carburizing. We cannot able to tell. The welder have to take the gun, he have to regulate the valves in such a way the flames comes out. He understand now this color belongs to oxidizing color, this color belongs to carburizing color, and then he started to weld or otherwise the cutting or otherwise heating part of the respective process. Therefore, this is very important. So inner white cone, there are two types of cones are there. So one is inside and one is outside. This we have observed in our home also. When you are on the stoves, the light color comes out. Likewise, okay. So inner white cone is 3100 degrees centigrade and outer blue flame. Inner one is the white, outer one is the blue, and then it is around 1275 degrees centigrade. So which is temperature higher? Inner cone temperature is higher. If we want to weld, we should keep nearer to this. If you want to do heat treatment, we should keep nearer to this outer temperature enough. The long distance we can maintain. Only 1200 outer body will, outer blue color flame will fall on the workpiece in such a way it can be carburized or it can be heat treated for some other purposes. Normal to 200, 400 degree heating can be done. So if in case I want to do welding, I want to go this 300 degrees centigrade to be in touch or very nearer to the workpiece in such a way this 300 degrees centigrade will fall on the workpiece in such a way the welding occurs or cutting process we can do. The length of the inner cone is the deciding factor of the arc length for cutting. See, arc length for cutting, the inner cone length. The length of the outer cone is the deciding factor for the preheating process. It is clearly given here. You see, the inner cone, they are talking about the inner cone. The inner cone is deciding for the cutting process and the outer cone is deciding for the preheating process. So for two purposes we are heating the flame. Outer for preheating purpose, inner for the, because inner cone is 3100 degrees centigrade. So likewise. So another one, see, for the flame of a carburizing flame, here I want to do the heat treatment process. See, the mixture of acetylene and oxygen is supplied here. Yes, okay. The remaining unburned fuel gas forms the additional zone called the intermediate third feather zone. Here one more feather zone also comes because the ratio differs. 1:1, the ratio we are differing in the carburizing flame. Acetylene is higher than that of the oxygen carburizing zone. So what happens here? The inner cone is around 2000. Is around 2900 degrees centigrade. There we have seen oxidizing process 3100 inner cone. Here we are seeing 2900 degrees centigrade. It is an inner cone. The outer cone similarly it is lesser than that of that, maybe 1270, 1260 degrees centigrades. Likewise we can see. So finally, I am dividing into three categories on the basis of supply of proportions. The acetylene and oxygen flames can be divided into three categories of neutral flame, carburizing flame, and oxidizing flame. So one by one we should see now. So number one, I have taken as a neutral flame. What for the purpose of neutral flame? For welding we have told. Neutral flame is obtained with equal number of oxygen and acetylene. So these both are important. Are mixed and burnt at outlet welding at the ratio of 1:1. That is important. The flame consists of two sharply defined zones such as the inner white cone, we have seen 3100, and the flame cone outer envelope of the blue color. See? So they have neatly given. So this one is blue, this one is inner zone is white. In this flame, none of the two gases are supplied in excess, no excess, none, no excess. That is nothing but a 1:1 we are supplying. This flame is white cone, has a maximum use of successful welding of many metals. So we came to the application now. So 3100 used for welding. How much temperature they have given here? 3100 degrees centigrade, 3000. Yeah. This I have mentioned in the table. You should see now. So about neutral flame. So this is how it looks. Mixing of oxygen gas, oxygen in the welding zone. So neutral, the ratio of oxygen, oxygen in the mixing in the ratio of 1:1. Please keep remember 1:1. So flame, an inner cone, the outer cone, inner cone degree centigrade around 3300 to 3100, and outer cone around 1000 to 260 degree centigrades are available. This is for neutral flame, purpose of welding. Now we came to the oxidizing flame. Here oxygen is extra, oxygen is additional. If more oxygen, see the word, they are starting more oxygen is added, the cone becomes darker and more pointed. Here it is a sharp inner cone and become more pointed also now. Pointed where the envelope becomes shorter instead of long pointed, the envelope becomes somewhat shorter. Outer, the envelope is something but outer. Becomes shorter and more fires called as oxidizing flame. This flame has an excess of oxygen. Excess of oxygen, this word are interrelated. See, more excess of oxygen over the required of the neutral flame. Oxidizing we are talking, so oxygen to be 1.5 and then C2H2 to be 1. In such a way, oxygen to be higher. To have this flame, set carburizing flame first convert into neutral. Neutral 1:1 we have kept. And then reduce the supply of acetylene to get the oxidizing flame. Has the highest temperature about 3400 degrees centigrade, 3100, 2300, and that range it is higher. So likewise the cone will be the shorter, pointed. See, the cones are shorter, pointed. How much degrees now is there here? So it belongs to 3300, 3400, and this range belongs to outer cone belongs to 1260 degrees centigrade. Inner cone 3300, oxygen is addition extra more than that of the acetylene, oxidizing flame. Next one. So we go on for this last one, the carburizing flame. Now here what happens? Oxygen is less than C2H2. It means 1 less than 1.5. That is to be extra. Carburizing, we are going to heat treatment process, cutting over. This flame is obtained on the excess of acetylene is supplied than which theoretically required. This flame is identified by the 3 zones of inner cone, which is not sharply defined. Inner cone is not sharp, no more heat, only heat treatment we are doing. And outer envelope is the same in case of neutral flame, somehow it is long and 1260 degree uniform, and middle zone surrounds the inner round extended to the outer envelope. It is white color due to excess of acetylene. Excess of acetylene, in the middle one more flame is formed, that is called as 1.5. C2H2 is found there, excess, because oxygen is additional over the oxygen. There is no mixing, the heat is not found. That is to be exacted. Larger and amount of acetylene larger will be in the lengthwise. So we see the image also. See likewise. What happens? The inner cone, which is a bright luminous inner cone is there. Here temperature is lesser than that of neutralizing. So, and inner cone also reduced acetylene, which is unburned acetylene comes out, unburned, because heat is not equal. So unburned acetylene will come. Heat, acetylene is there, making the intensity of heat, generation of heat, chemical reaction not takes place equally. Therefore, it also comes out, which is in the like a one more reduced zone like a feather, and one more the blue color flame comes out at the last. The outer cone is in the blue. So this is about the carburizing. The proportion of acetylene in the mixture is higher. Acetylene is higher than that of the required to produce a neutral flame. Whatever we are doing for acetylene is higher than that of neutral. We have already done. neutral 1:1, carburizing, oxygen and C2H2. So how we can do this now? Carburizing, here it is 1.5, 1. Neutralizing 1:1. And then the oxidizing, we have to put oxygen additional 1.5, 1. So such wise we can able to make the sketch for carburizing, neutralizing and oxidizing. So these are the applications we have seen. This kind of flame used in the, so welder has to find this. It looks like this. See, each, as a normal person, everything is the same. Everything looks the same. But the welder, the skilled welder find this. How? Due to this sharp white color, the flame it is neutral. Oxidizing, the pointed, and then the long blue color flames are feathered. It comes oxidizing. And here, see, it is also comes and light feather is there. 3 layers are there. So it is a carburizing flame. They are finding. So by seeing this flames itself, we should find what's happening, how it can be classified. So as I told you, the nozzle differs from these things. How this nozzle differs? The welding tip looks like this. See, the welding tip. Oxygen value through the regulator we are adjusting 1:1, 1:1.5. Which one is 1.5? That we are adjusting here, and in this mixing happens and comes out. This tip, here the regulator which will be in the cylinder. In this tip you see, as a single point of hole is there, and from preheating purpose we have multiple holes. In the same way at the jet, oxygen jet also comes there. So by this, the cutting tip contains more oxygen should come. For a single tip neutral, we can take a single hole in such a way, simple equal number of 1:1 ratio will comes. Here multiple ratio of will come there. So we can oxygen if needed more, it is separately coming in the separate hole. Oxidizing process. In the single center hole, it comes in the equally mixed process. If we need oxygen, we can give more.
Okay, now I'm going to show you some aluminum welding using the DHC 2000. We're going to do some thin body aluminum here. It's 035, and I'm also going to show you some cast aluminum, how we repair a cast water pump, might be a water jacket. We can do it all with the torch. So let's go here and do the body aluminum first. I'm running at 4 pounds of oxygen and acetylene. Let's go ahead and do this weld. I'm going to use a nice soft neutral flame. This torch is very good at low pressure. It allows us to do the real thin aluminum. I use a little Harris high temp on our flux. That allows me to get rid of the oxidation on our aluminum. And let's go ahead and weld this up. We're going to preheat, and we're going to dip in and dip out like we're TIG welding. Here's my welded side right here. Gives you a nice clean weld, 100% penetration to the backside, and the nice part about it has an annealing effect. Actually softens the metal. Now I can English wheel this out, I can hammer it, hammer weld it, bend it, shape it, any way we need to go.
If you're looking for a complete welding and cutting system in one great kit, then you need to check out this ProMaster Gas Welding Torch Kit from Eastwood. It has everything you need to cut and weld steel, stainless, aluminum, cast iron, and cast aluminum. And it all comes in one convenient carrying case. You get the pistol grip torch gun that will allow you to cut everything from thin sheet metal to 1-inch thick plate. You get 9 welding tips from 13 thousandths up to a heavy 3/8 cut. You also get curved and straight extensions to help you get into tight areas. It comes with over and under cutters. The undercutter will allow you to do fine sheet metal work, and the overcutter is for heavy plate. You also get guide wheels for long straight cuts. It also comes with an acetylene tip for body leading and soldering.
Okay, see, I have taken fuel gas of acetylene in this setup, and then The oxidizing, that is what we have seen now. What we have seen, this is what oxidizing, neutralizing and carburizing. So oxidizing, for oxidizing, okay, for neutral, equal oxygen, acetylene is equal to 1. What I told, the temperature, inner cone is around 3200, outer cone is around 1275. Okay, we understand. Now I am increasing for the oxygen, oxidizing. Oxygen is greater than the fuel gas. Fuel gas nothing but acetylene. How about the temperature? Here oxidizing higher cutting, you should go for cutting. So the inner cone is around 3300 degrees centigrade, outer cone around 1275. Okay. And now again, third one, the carburizing. What happens here? Carburizing C2H2 to be higher. Here the oxygen to be higher. Here is 1:1. Oxygen is less than fuel gas, acetylene. So temperature similarly 2900, heat treatment only. So it is the last one. Carburizing is less temperature than that of the oxidizing, than that of the neutralizing. 2900 degrees centigrade. Now the outer one also 1260 degrees centigrade. So you see applications. The flame oxidizing, neutral, carburizing I have added. The inner cone, the white, sharp, pointed, short. Similarly for neutralizing, white, sharp. Similarly for carburizing, the last one we have seen, the luminous, bright illuminating, non-sharp. For heat treatment, non-sharp. These two are sharp. This is non-sharp. Please remember. Here the middle feather is not there for first two. Here it is not there. Here it is not there. But for the carburizing flame, we are taking the white feather. Small white feather we have seen. Outer flame. It is a blue narrow shaft. Yes. Second one also blue sharp. Yes, we have seen. Outer also blue sharp. This is all okay. But first one is only this oxidizing having short. Why we are using applications? We are using for cutting of oxidizing flame, and then for welding, for the neutral flame, and then for the heat treatment, hardening process, hardening of the surfaces of the carburizing treatments. In such a way, we can able to go for the understanding. The oxygen fuel, what we are doing in case of cutting, we are using such cases. In case of welding, we are using the neutral flames. So oxyacetylene gas welding is nothing but a oxygen plus acetylene. Oxyfuel, oxyacetylene. We are comparing. We are taking oxygen, fuel, as it is having high intensity, we are going for the acetylene purposes. And accordingly, oxidizing temperature is higher. Oxidizing temperature is higher than that of everything. So now we come to this advantages of oxyfuel welding / cutting. Because we are going to use this neutral flame oxidizing cutting process and increasing of this hardening process. Therefore, welding and cutting are the same with respect to change in the nozzle. What are the advantages? The equipment is versatile, low cost and self-sufficient and usually portable. So it is a small machine with a nozzle at 2 cylinders. We have seen the image also. So it can be easily taken over to any portable places. It includes the ability to control heat input and bridging large gaps, avoid melt through and clearly view in the weld pools. Carbon steel sheets formed in the variety of shapes and can often be welded more economically by the oxyfuel welding than with the others. So it is telling various shapes can be welded. Any designs, complicated designs, any positions also. We have seen 1G position, 2G, 3, those any position can also be done here. Oxyfuel gas welding is capable of joining a small diameter carbon steel, small diameter also possible, up to maximum of 75 mm diameter also possible, right? And a pipe with a wall thickness of 4.8 mm, small or large thickness also possible. In this situation, I want to show you, this is the diameter, and we have inner length. This is the thickness of the pipe. So we are talking about this 4.5, and again this outer diameter also. Okay, both are possible or by these cases. So here you see, as we have told you, this inner and outer cones. So as I have told you, this inner cone and middle cone and outer cone. You should remember, inner flame having the highest temperatures and outer flame having the innerst temperature. What is this inner and outer? So here, so in this picture I can able to show you this flame temperature in the y-axis we have taken. Here we have the flame temperatures. The outer point having the lowest temperature point here, and then it increases up to 3100 degrees centigrade here. It means this belongs to inner cone having the highest temperature as compared to the outer envelope. Such things we understand from the graph. So this is having the 3300 degrees centigrade and the outer envelope having 1260 degrees centigrade. So simple things we are understanding. So similarly the limitations, it is unsuitable for the refractory metals such as niobium, molybdenum, tungsten and tantalums, and also it is unsuitable for the reactive metals such as titanium and zirconium also not possible. And one more, the main important disadvantage is here. What it means, due to this heat input availability, due to this chemical reactions, heat formations, there is a chance of making the crack in the weld metals. So rapid heating, rapid cooling process, so that causes the propagation of crack in the specimens. So that is also not recommended. Not recommended means that have some limitations. High heat should not be provided. Right. So what is the applications then here? So applications mainly, maybe the cutting, maybe the welding, maybe the heat treatment, we see. It is used for preheating or post-heating, welding before and after. For the heat treatment process we use. For welding, brazing and oxygen cutting process. Oxygen cutting process we can use. And also for repairing also we can do. And also we can use for field works and the repairing process also we can able to do. Metal that can be oxyfuel welded, mostly ferrous and non-ferrous are possible. Mostly all non-ferrous metals, stainless steels, all are possible by these materials. We understand this comparison of gas welding process and gas cutting process. Setup is same. How the nozzle it differs, right? So the summary of this session. So the summary. In welding classifications, we have seen today about the gas welding process, and then also the gas cutting process. In this we have used the fuel gas of acetylene of C2H2. So oxygen plus C2H2 gives the oxyfuel welding. So that is how we have seen about types of flames: neutral gas, oxidizing flame and the carburizing flame. The remaining part of the subject we will see you in the next session. Thank you.